Hello everyone, I'm Joey. So now let's look at the overview of our system. So in our broad diagram, the system is divided into three main sections: input, controller, and output. So on the left, we have our input, a pedestrian sensor, which is a push button. So this sends a signal to the controller when a pedestrian wants to cross. So in the center is the controller, the ARM Cortex-M4. So it processes the input and controls the timing logic. So on the right are the outputs. So we have a 7-segment display to show the countdown timer, and also two LEDs are red and green to act as the traffic signals.
Hello, welcome everybody. Today I will be explaining the schematic design for our microprocessor project. So as you can see here, I'm using an STM32 microcontroller to drive a 7-segment display, two LEDs, and a push button. So let's start with the 7-segment display. So as you can see here, the 7-segment display is wired as common anode, meaning both common pins are connected directly to VCC. Each segment, A to G, is connected to a GPIO pin through a 220 ohm resistor. Because it's common anode, the segment turns on when the GPIO is low and off when the GPIO is high. So the logic is inverted compared to common cathode displays. Then we go to the LEDs. So as you can see here, the LEDs are wired as active high. Each LED is connected from GPIO pin to resistor, LED, and then to ground. As you can see here, when the GPIO pin is set high, current flows and the LED turns on. When the pin is low, the LED turns off. Finally, the push button, which is right here, is wired as active low. One side of the button goes to the ground and the other goes to the GPIO pin. The internal pull-up resistor is enabled in the software. So pressing the button pressing the button pulls the pin low. Overall, this design uh, mixes active low and active high signals, which is completely fine as long as the firmware can handle the logic completely. Thank you for watching.
Here is the setup for the project. Now if you see here, the red LED is already on, and which means the pedestrians are not allowed to cross. It's red for them. So this is the setup basically. We have a 7-segment display, the resistors there, we have the green LED, and we have push button which is active low. This is wire is the ground that makes active low. When the push button is pressed, it detects ground or zero logic. So let's see here. We hold the push button for 1 second because that's the instruction we are given. 1 second. Then after that it starts counting down. So 9, and after that countdown, the green LED is on, which means the pedestrians are allowed to cross. Now, after the countdown is off, the LED is going to go to red, which means the pedestrians are no longer allowed to cross. So, let's do it again. Press. If I just press click like that, without waiting for 1 second, nothing happens. See? Nothing happens. Let's wait for 1 second, press and 1 second, then the counter is going to start. Yeah, like that.
So we start with the main program flowchart where we initialize the GPIO port, so the red LED will be on and the green LED will be off. Then the 7-segment display will be off. Then we initialize the red push button, and given a choice, if the button isn't low, then loop forever and return to main loop. But if the button is low, we start the 1 second timer. Then if it's still low after 1 second, return to the main loop. Next we have the countdown subroutine, so start. If the button isn't pressed for 1 second, then return. If pressed, trigger the countdown timer. Then set the counter to 9, which will turn on the green LED and the red LED will be off. So then display on the 7 segments, then delay for 1 second. If the counter is more than 0, return to main countdown on 7 segments. If 0 or lower, then red LED will be turned on and the green LED will be off, and the 7-segment display will be off. Then return to start. Thank you.
So for the start of the code, we have defined some macros here to help us code. The first one we have is output data register 1, which makes the pin that's initiated here and the pin number 1. This one is for 0, and this one it reads from the pin. So let's go to the main code. The main code is here. So we have the first function, which is set idle. Set idle, basically what it does is it sets the green LED on, green LED off, and the red LED on. Let's check here. Green LED off, red on. Now we have the while loop here. The while here checks if the pin is detecting 0. The push button P0 is detecting 0. If it detects 0, it will give it 1 minute, 1 second. If it's still detecting 0, it will start the countdown of the 7 segment from 9 to 0, decrementing by 1, and each iteration is going to wait 1 second. Then after it's done, it's going to set all of the segment into 0. If you see here, we have all of them being set to 0. Now, if the person is still pressing, then the whole process is going to start again. Now let's see some of the functions we have here. The first one is we have segment show. The segment show, basically it maps these values which are defined here, which shows, like for example, which one goes on and off. It maps to the pins. So for example, is it 0 or 1? Do we make it 0 or 1 like that? And the pins we used here are A1, A3, 4, 5, 6, 7, then P5. And I think that's the